So I think this should be our last video on 5.2, which is about special graphs and terminology. So we still have one special type of graph that we want to look at called the complete bipartite graph. Complete bipartite graph on m plus n vertices. So you have a total of m plus n vertices. It's going to be denoted KMN. KMN is the notation for the complete bipartite graph on m plus n vertices. It's a bipartite graph, so it's a graph that can be bipartitioned, where half of your vertices are in one set, half of your other vertices are in this other set. So the first set's going to be called V1, that's going to have m vertices. Your second set's going to be called V2, that's going to have n vertices. And there's going to be an edge between every vertex in V1 and every vertex in V2. That's what makes it the complete part, right? Every vertex in V1 has is connected to every vertex in V2. So that's why we call it complete bipartite. Bipartite. Let's do an example. Let's just look at some examples. I don't even need to write examples. Here I'm going to write K11. K11. So here on the left side, this is going to be my V1. I'm going to have one vertex. On here on my right side, this is my V2. I'm going to have one vertex. And then we're just going to connect every pair of vertices between the left side and the right side. So that's what K11 looks like. Let's do K12. So K12, your left set, V1, is going to have one vertex. And your right set, V2 is going to have two vertices, and you're going to make connections between V1's vertices and V2's vertices. You're going to make connections here. How about K22? That means you're going to have two vertices on the V1 set and two vertices on the V2 set, and you're going to make all the connections you can between the left side and the right side. So you're going to go, that goes to that, and then the second vertex has to go to the others. How about K23? Means we have two vertices in V1, it's the left side, and three vertices in V2 on the right side, and we're going to connect. This vertex, first vertex goes to all three on the right, and the second vertex goes to all three on the right. All right, what else? What haven't I done? I haven't done K33, have I? That means I'm going to have three vertices in V1 on the left, three vertices in V2 on the right. I'm going to make my first vertex is going to go to all three on the right. My second vertex is going to go to all three on the right. My third vertex is going to go to all three on the right. That's K33. How about, let's just do K36 just for fun. K36. I'm going to have three vertices in V1 and six vertices in V6. So I'm going to take my first vertex, I'm going to go to 6 places on the right. My second vertex is going to go to 6 vertices on the right. My third vertex is going to go to 6 vertices on the right. And it gets messy, right? All right, so here's the question. Fact. How many vertices does KMN have? Not vertices. We know it has m plus n vertices, right? You have m on the left, n on the right, so it has m plus n vertices. How many edges does it have? KMN has how many edges? M times n, right? Edges. Pretty easy, right? So you have m edges, right? And I'm sorry, m vertices on the left side. And each of those m vertices are going to have n and edges coming out of them because they're connecting to the other n vertices. So you just have n plus n plus n plus n plus n plus n, m times, so you have m times n. Yeah. Not going to bother proving that in detail, just mention that. Let's see. All right, what else? Some other terminology we want to look at. Yeah, so let's just follow this up. Here's like just a question, just an example. How many edges does K11, let's do 10 have? Well, you just take what, 11, so the number of edges here will just be m, which is 11, times 10, which is 110. Number of edges is 110. All right, okay, now on to new terminology. Just want to throw that in there real quick. Definition. A subgraph. It's basically a graph that's inside of a graph. A subgraph of a graph G, remember G consists of two things, a set of vertices and a set of edges, is a graph we're going to call H. It's going to have a set of vertices W and a set of edges, which we're going to call F, where the vertice set W is a set of the vertex set V, and the vertex set F is going to be a subset of the vertex set E. So W is a subset of V, and F is a subset of E. That's what a subgraph is. Example. Let's look at C5. Remember C5 is a cycle with 5 vertices. So if I have V1, V2, V3, V4, V5. I'll start at V1, I go to V2, V2 to V3, V3 to V4, V4 to V5, V5 to V1, that's C5. And I have over here W5. So you got 1, 2, 3, 4, 5 vertices on the outside. Then you got a middle vertice, right? Vertex. V1, V2, V3, V4, V5. And then a V6 here in the center. So I connect V1 to V2, V2 to V3, V3 to V4, V4 to V5, V5 back to V1, but then I got to connect everything to the center. So note, C5 is a subgraph, of W5. Why is that? Well, every vertex that's in C5 is also in W5. And every edge that's in C5 is also in W5. It's just that W5 has some extra edges that C5 doesn't have. Okay. Here's an example of a subgraph. I think the last thing we want to do, we want to look at the union. What happens when you union two graphs together? So remember, a union is when you put things together, put two sets together. Definition. A union, so we're defining of two simple graphs G1. So your first graph is going to be called G1. It's going to have a vertex set of V1 and an edge set of E1. And the second graph, G2, is going to consist of a vertex set V2 and an edge set of E2. And the way we're going to denote the union of two graphs, denoted, we're going to call it G1 union G2. The union is the simple graph with vertex set So remember, when you take a union, you just put things together. So the vertex set's going to be V1 union V2. So you're going to take the previous two vertex sets from G1 and G2, which are called V1 and V2. I'm just going to union those together to get the vertex set of G1 union G2. And the edge set and edge set. So you can imagine what's going to happen to get the edge set here. You're just going to take the E1 and E2 and union those together. Yeah. Okay, so I'm going to take E1 and E2. I'm going to union those together. E1 union E2. Just put them together. Okay, so let's just do a quick example of unioning two graphs together. Taking the union of two graphs. Sketch the union of G1 and G2. Okay, so I'm going to draw a picture. There's going to be G1 down here. ABC. Here I'm going to have F. Here I'm going to have E. Here I'm going to have D. Okay, that's G1. Here's G2 over here, another graph. A, B, D, E, F, H, G, and connect F and G. Okay, so we want to union these graphs together. We want to put them together, basically. So basically what I have to do, I have to keep the points from every single graph. So I'm going to take A, B, C. I have to include those. I have to include D, E, and F. So those are all the points from the first graph. And we have to include all those edges. A to B, B to C, B to E, B to F, D to E. Okay, then we have to look at our second graph and we have to include that information. So we have to include A and B, those points, we have them already. E and D, we have them already. We have to include F, we already have it. We have to include H, we don't have it, so we're going to have to add H in here. We have to include G, we don't have that. And we're going to have to include all the edges. We already have AD, no we don't have AD, so we have to add AD. AB we already have. DE we already have. BE we already have. BF we already have. FH we don't have, so we have to add that. FG we don't have, so we have to add that. And HG we have to add that. So your final graph is going to be this graph I'm going to make in purple. I'm going to use purple. It's the red together with the blue mixed together. So it's going to be this guy. It's just combining the two graphs into one, basically. It's a combination of these two graphs into one, composing these two graphs together. Yep, that's it. This is G1 union G2 right here. This graph right here. The union of two graphs.